Hello dear students, we are going to discuss about amines chapter. Mainly first we are going to discuss reduction of preparation of amines. In that the first reaction, reduction of nitro compounds. So nitro compounds converted into amines, just replacing oxygens with hydrogens with the help of these reducing agents. So Sn plus HCl, Fe plus HCl and H2 plus Ni. Along with this we can also use some more reducing agent, Zn plus HCl and Fe plus HCl and NH4 twice SH and sodium amalgam with ETOH. So this reagent especially we use for a reaction called as Mendes process. So in this case Cn converted into CH2NH2. So this is also one of the named reaction called as Mendes process where Cn becomes CH2NH2. So these all are the reducing agents which are used to reduce amines, reduce nitro compounds to amines, and we can also reduce some other compounds with the help of these reducing agents. Those are NO2 to NH2 and Cn2 CH2NH2 and NC like isocyanide to NHCH3 and CONH2 to CH2NH2 and aldoximes. So R CH double bond NOH can converted into R CH2NH2. That means aldoxime converted into respective primary amine. Same way ketoxime also can converted into respective secondary amine, primary amine. RC double bond N OH can converted into R2 C H NH2. So this is how the reduction takes place with the help of these reducing agents. Coming to the second reaction, that is about ammonolysis. Ammonolysis of alkyl halide. So here ammonia with Rx. So here NH2 minus replaces X minus of Rx and get primary amine. So this follows SN2 mechanism. That means nucleophilic substitution reaction. NH2 minus replaces X minus and get primary amine. Further adding of Rx will get secondary amine. Just same like repetition process. So further adding of Rx will get tertiary amine. That is over addition of Rx will get quaternary ammonium salt. So in this process we are going to get all the type of amines. So it is not suitable method to prepare specific amines. So that's about ammonolysis of alkyl halide. So in this case the tertiary amine with Rx we are using to get quaternary ammonium salt. In the place of R, either primary and secondary should be used to get quaternary ammonium salt. If you use tertiary amine, that is not going to give this reaction. Coming to next one, reduction of nitriles, same like above. So Cn converted into CH2NH2. So we use reducing agents. So those are H2 nickel PT or PD. So sodium amalgam with alcohol and LiAlH4 lithium aluminum hydride. These are strong reducing agents. For this conversion, if we use this reagent, not this reagent, then we can call it as Mendes process. Mendes process. So coming to the next one. So here this side, reduction of amides. So amides converted into respective primary amine with the help of lithium aluminum hydride in presence of aqueous medium. And Gabriel phthalimide synthesis, most important. So here phthalic acid first converted into phthalic acid converted into phthalimide by adding 2 moles of NH3, and after heating it lose water as well as NH3 and converted into phthalimide. So this phthalimide in presence of KOH and RX you will get, and further we hydrolyze also with the help of basic medium. So finally we get sodium salt of phthalic acid plus primary amine. This is our main product. So this process is used to prepare mainly for primary amines. This also is an example of nucleophilic substitution reaction. So that is why aryl or vinyl primary amines not possible to prepare with the help of this reaction due to partial double bond character in the place of aryl or vinyl halides. So that you might studied in case of first haloalkanes chapter. So that's what. So it is mainly used for the making of primary amines, and this process is not helpful to prepare vinyl or aryl primary amines. So that's the most important point. Coming to the next most important reaction, Hofmann degradation or Hofmann bromide reaction. So amide in presence of Br2NaOH will get primary amine plus Na2CO3 and NaBr and H2O. So here few things you have to know. Suppose at the reactant side number of carbons are n plus 1 and product is having only n number of carbons. That means the CO whichever is there in the amide, that is converted into in the form of CO3 minus 2. This is very important question. The amide CO coming out as CO3 2 minus, along with that the remaining products are forming. And here the stereochemistry of reactant whatever is there, the same stereochemistry observed in case of product. So retention product is major product, not inversion product in this case. And coming to the next, the intermediate in this reaction is alkyl isothiocyanate. So you can write those points, some important points for this. So the first point is Hofmann degradation process. In this case, alkyl isocyanate is the intermediate. And coming to the second important point, aryl or vinyl amines not possible to prepare by Gabriel phthalimide reaction or Gabriel reaction due to partial double bond character. So these are the important points, and we can also prepare secondary or tertiary amines with the help of Gabriel phthalimide synthesis. So these are the important points, so just carefully can note these things. So come back to the next reactions. So stereochemistry remains same in this case. So that's what the main important point about this reaction. And coming to the next, so there are some additional reactions. That additional reactions comes in JEE and NEET exams, so that we will discuss after completion of total chapter. So these are the important reactions till now what we discussed. And coming to the physical properties, so basic strength of the amines. So in gaseous phase, so tertiary amine greater than secondary amine greater than primary amine. So because in gaseous phase only inductive effect will consider. So wherever more positive I groups are there, the basicity will be more for that. And in case of aqueous phase, so that depends on the methyl depends on the alkyl groups, we can decide the basicity of amines. So in case of aqueous phase, so 2 1 3, if you take R group as methyl group. Suppose if you take R is ethyl group, the answer is secondary greater than tertiary greater than primary. So that is what. And the overall, the basic strength mainly depends on the all plus I groups like plus M plus R plus I groups plus H groups, and inversely proportional to negative groups. So here also we can add one more very important point related to this. So what is that we can discuss? So here basicity is directly proportional to plus groups and stability of conjugate acid and Kb values and inversely proportional to basicity is inversely proportional to pKb values, oxidation state of central atom, and percentage of S character. So these are the important points for basicity of amines. So based on this, we can see like there are different type of questions. So just a simple example we can use. The suppose if you take this H2. So here in case of cyclohexylamine, the percentage of like the nitrogen lone pair, nitrogen or amines basically leave its bases. It ready to give electrons to the outside species, so that these are called as electron donors. So it depends on the group connecting to nitrogen, the basicity of amines can be decided. So in this case, this carbon is single bonded carbon, so hybridization of this carbon is sp3, but in this case hybridization of carbon is sp2, because double bond is present, it is called as aniline. And in this case the double bond is there, but it is far away from the nitrogen, so there will be no conjugation. But in second option there will be a delocalization of conjugation. So this lone pair busy in the involving of resonance, but here it is not involving. In this case, first case also not involving in resonance, but the difference is in first example all carbons are sp3 hybridized, so less percentage of S character, because sp3 in that percentage of S character is 25. But in this case one of the two carbons are sp2 hybridized, so that percentage of S character more in this example as comparatively first example, so that basicity will be, the answer is like this. So 1 is greater than 3 greater than 2. This is how we can discuss basicity of amines. So there will be lot of examples related to that, like heterocyclic compound, all other things that we will discuss at end of this class. So just we are discussing the total chapter in one short video. So that's why we will stop discussing now and we'll continue further reactions. So come back to this one. So this is next reaction, alkylation, same chemical properties of amines. So here chemical properties means alkylation or ammonolysis, it is same as the making of primary amine from ammonia. So ammonia, when it react with Rx, so it keep on replacing X minus with NH2, and this will continue, like it will give primary amine, that further addition of Rx will get secondary amine, keep on continues, that we are calling it as alkylation or ammonolysis process. Coming to acylation, very important reaction. So primary amine, when it reacts with RCOCl, so loss of HCl, because nitrogen is having good protonating group, so it will give H plus ion easily, and this Cl minus ion will come out, and by loss of HCl the remaining two things will combine, which is nothing but amide is formed. So similarly RNH2 with acetic anhydride or any anhydride, it will break as like this, and here H plus replaced with this RCO plus group. So that's how amide is formed. So what is formed here? So H plus, that H plus attacks to O minus, and this RCO plus combines with RNH minus. So that's how the amide is formed, along with that acid is formed. Coming to very important reaction is carbyl amine test. So carbyl amine test is most important reaction for testing primary amines. So primary amines converted into isocyanide in presence of CHCl3, means chloroform and NaOH or KOH. So this alkyl isocyanide is foul smell compound, and even Bhopal tragedy also happened with methyl isocyanide. So this is isocyanide is more dangerous, even cyanide also more dangerous. So this is foul smell compound which is formed from the primary amine with chloroform and KOH. Here chloroform and KOH, the same reagent we have used in Remer-Tiemann reaction. This chloroform and KOH produces CCl2 intermediate. So CCl2 means CCl2 is dichlorocarbene. This dichlorocarbene is neutral electrophile. This neutral, due to presence of 6 electrons in its outermost shell, it acts as a neutral electrophile. So total how many electrons? Carbon total electrons are 4 including this lone pair, and 2 electrons from chlorine, together is 6 electrons. So it ready to accept 2 more electrons to get octet configuration. That's why it is electrophile. Since there is no positive or negative charge over this, it is called as neutral electrophile. Anyhow, this is singlet carbene is the intermediate. Singlet dichlorocarbene as an intermediate in this process. And here all primary amines can be tested with carbyl amine test. So isocyanate test for both aliphatic and aromatic amines, very important. Aniline can give this reaction, but in case of Gabriel phthalimide, aniline or vinyl amines cannot be prepared. Coming to the next reaction with nitrous acid, this is most important reaction. So these are the two reagents which are used to separate primary, secondary, tertiary amines. The first one is reaction with nitrous acid. So aliphatic amines, aromatic amines, primary, secondary, tertiary, how it will react, everything we can see here. So case 1, aliphatic amines. So primary amines converted into a carbocation over HNO2. This HNO2 is formed with NaNO2 plus HCl. That is nothing but just this together will give HNO2 or HONO will get carbocation. See, this carbocation is possible to form only with primary amines, primary aliphatic amines. So after that the OH minus will attach to this and get primary alcohol will be formed. Here, since carbocation is an intermediate, before formation of alcohol there is an option to undergo rearrangement. That's also very important point, students. Coming to next, primary amine converted into NaNO2 plus HCl to get diazonium salt. Further heating it lose R plus and finally alcohol is formed. So coming to aromatic primary amine. So in case of aliphatic, carbocation is the intermediate, but in case of aromatic, only benzene diazonium chloride is the intermediate. This will form only 0 to 5 degrees Celsius. If it is more than that temperature, this lose N2 and get PHCl, means chlorobenzene is the product. Coming to secondary aliphatic or aromatic amines, how it will react. So here secondary aliphatic amine with HNO2 will get electrophilic substitution reaction. So that means NO plus replace H plus of secondary amine, students. So nitroso compound is formed. This is yellow oily compound. Coming to next one, case 4. So tertiary amine, tertiary aryl amine with HNO2 will get, so we can get this compound. So the compound is NO NR. So in case of aliphatic tertiary amine, this is aromatic tertiary amine. What happens here? This is the product. In case of aliphatic tertiary amine with HONO or NO plus will get R3N NO. Coordination covalent bond is formed with tertiary aliphatic amine. This product is formed with aromatic primary amine. So these are the this is very important reaction to separate or to differentiate primary, secondary, tertiary amines. Coming to the next reaction is Hinsberg reagent, Hinsberg test. This is most important for board exams also. Hinsberg reagent. So primary amine, secondary amine, tertiary amines can be separated with this reagent. So Hinsberg reagent means benzene sulfonyl chloride. So this benzene sulfonyl chloride, when it react with primary amine, lose HCl. As normal, most of the amines reactions lose HCl and add the product, like substitute the product. So here H plus Cl minus loses as HCl and get this soluble compound in base, like it is one of the adduct is formed. After that it's soluble in alkali in presence of KOH solution. So what happens is this H plus ion take out by OH minus or alkaline medium, which is nothing but soluble product. So primary amine gives soluble product with benzene sulfonyl chloride. Coming to secondary amine, so here also loss of HCl. Once loss of HCl is formed, this is the product. So this nitrogen doesn't have hydrogen, so it is not going to react or soluble with base or KOH. So insoluble product given by secondary amine. Tertiary amine, no reaction because there is no hydrogen with nitrogen. That's how the reaction takes place. Coming to electrophilic aromatic substitution reactions with aniline. So aniline converted into tribromoaniline in presence of Br2 water or Br2 CS2. So basically Br2 CS2 means only para is formed. ortho or para, but with Br2 and water we will get all the three places Br will be added. And monobromination, so monobromination here also tribromination only happens. For making monobromination, first we will protect NH2 group with acyl group, acyl chloride. So acetanilide is the product, acetanilide. So here acetanilide is less activating group than NH2 group, because NH2 is strong electron donating group or plus R group. It will activate the ring so that more electrophiles can attack ortho and para position, ortho para positions. But when we protect with CH3COCl, we get this one, which is called acetanilide. Acetanilide is mild activating group, means this group is not that effectively give electrons to the benzene ring, so that only para-bromo compound is formed. After formation of para-bromo compound, later we will do hydrolysis so that it will break bond as like this, and H plus attack here, and we'll get the same amines. So para-bromo aniline, if you want to make, this is the best method. First protection of NH2 group with acyl chloride. Later we are adding Br2 in presence of acetic acid, means non-polar solvent. We'll get only para-bromo aniline at end after hydrolysis. Coming to nitration, very important. Aniline over nitrating mixture will get all three products. Till now we have discussed that NH2 is good activating group, but we are getting even ortho meta para compound. So here the important question also there. Ortho gives how much? Ortho nitrophenol and para nitrophenol and meta nitrophenol. So meta also possible to form. Generally, if the benzene ring have electron donating groups or plus groups, only ortho or para will be formed. But in case of this example, even meta is forming, which is 47%. So the reason behind that, since it is having nitrating mixture is having strong acids, so NH2 is base, Lewis base, what happens is just NH2 becomes NH3 plus, which is nothing but anilinium ion. So these are strong deactivating group to the ring. Then what happens? The positive charges formed over ortho and para during resonating structures. So meta alone empty, like beta alone no charge, so that the electrophile NO2 electrophile possible to attack where there is no positive charge. That's how the meta nitro aniline also as one of the product. So highest is para, which is 51%, lowest is ortho, which is just 2%, and this is 47%. Coming to sulfonation, it is just this is base, this is acid, so we'll get adduct product or salt formation. Further heating will get like benzene sulfonic acid, amino benzene sulfonic acid. And most important reaction is aniline doesn't give Friedel-Crafts reactions due to salt formation with AlCl3, because in all Friedel-Crafts reaction, halogenation or alkylation, we are going to use AlCl3 or FeCl3 as the reagent, that to anhydrous AlCl3, so that this anhydrous AlCl3 is neutral electrophile, because it has 6 electrons in its outermost shell, so it acts as a Lewis acid. So aniline is Lewis base. What happens? So aniline with AlCl3, salt will be formed instead of alkyl aniline or haloaniline. That's why aniline doesn't give Friedel-Crafts reaction. Just you can simplify as aniline gives salt with AlCl3, so it doesn't give Friedel-Crafts alkylation or acylation. So that's the only final reaction. And coming to Zwitter ion, Zwitter ion means at neutral pH or isoelectric pH, isoelectric pH. So NH2, this group NH2SO3H, if you take, this is basic group, this is acidic group. So at neutral pH or isoelectric pH, so H plus ion accepted by NH2 and becomes NH3 plus, and SO3 becomes SO3 minus. So that's how the Zwitter ion. Zwitter ion means the same molecule have both positive and negative charge. Here isoelectric pH is not always equals to 7. It depends on the Ka values of NH3 and NH2 and SO3H. That's how we can conclude this chapter. So all the problems, additional questions, additional things we are going to continue in the